Hello and welcome to yet another video of Cornerstones of Math. Today we will take a look at one of the most famous proofs that many students learn during their school years. When you were learning irrational numbers such as square root of 2, you might have learned how to prove that square root of 2 is irrational. In this video, let us generalize a little bit and let us prove that the nth root of 2 is irrational, where n is a natural number greater than or equal to 2. So if you have learned how to prove square root of 2 is irrational, you might already know the method. The proof by contradiction. But before we move on to that famous method, we have to admit that there are some properties that we use in that method without properly proving them. Basically, these two properties are used without proof in this proof. First, the nth root of 2 belongs to the set of real numbers, so that if nth root of 2 is not rational, then it is irrational. And second, any rational number can be expressed in the form of irreducible fraction a over b, which means that a and b are co-prime integers. These are the stuffs that can be proved using more advanced analysis and algebra, so in this video we will just take them for granted. Alright, now the proof by contradiction. So first, assume that the nth root of 2 is rational. Then, nth root of 2 can be expressed as a over b, where a and b are co-prime integers, but since we are dealing with positive numbers, let's just say co-prime natural numbers. Now, in order to remove this nth radical, we raise both sides to the power of n. Then, 2 equals a to the power of n over b to the power of n. Therefore, a to the power of n equals 2 times b to the power of n. Here, since the right-hand side is even, a to the power of n is even. And since a to the power of n is even, a is also even. Wait, how does this part work? Well, to explain this, we have to use some sort of mini proof by contradiction inside this proof by contradiction. You see, if a is even, then since an even number multiplied with another even number is still an even number, a squared also must be even, and then a cubed also must be even, and so on, so a to the power of n must be even. On the other hand, if a is odd, then since an odd number multiplied by an odd number is still an odd number, we have a squared being odd, a cubed being odd, all the way up to a to the power of n being odd. So if we assume that a is odd, then we have a to the n being odd, which contradicts the result that a to the power of n is even. Therefore, if a to the power of n is even, then a is also even. Now, since a is even, we can write a equals 2k for some natural number k. Then, from here, we have 2 to the power of n times k to the power of n equals 2 times b to the power of n. So we have b to the power of n equals 2 to the power of n minus 1 times k to the power of n. Now since n is greater than or equal to 2, this right-hand side is 2 times some integer, so it is even, hence b to the n is even. And here we do the same thing, since b to the power of n is even, b also must be even. Therefore, a and b are both even, which contradicts the condition that a and b are co-prime natural numbers. In other words, a over b is irreducible. Since we have a contradiction, we have the conclusion: the nth root of 2 is irrational. So that was the simple proof of the nth root of 2 being irrational. Normally, I upload my videos every 2 or 3 days, but my next video will be uploaded tomorrow. So please don't miss that one, and thank you for watching.